Our objective today, we want to be able to solve one-step inequalities using multiplication and division. Let's take a look at our key ideas for this lesson. We're going to be looking at the multiplication property of inequality, which says when you multiply each side of an inequality by the same positive number, the inequality remains true. For example, if we take a look at the inequality 8 is greater than 6, we know that 8 is more than 6. Well, if we multiply both sides of that inequality by the same positive integer, so if I multiply 8 by 2, we would get 16. If I multiply 6 by 2, I get 12. Notice that I still get an inequality that's true. 16 is more than 12. Let's take a look at another example. I have the inequality of a number divided by 4 is less than 2. Well, I can use my multiplication property of equality to solve that inequality, meaning find the value for x that's going to make that inequality true. What number, when we divide it by 4, is going to be less than 2? Well, we solve inequalities the same way we solve equations. And we solve the equations using the inverse operation. Well, because I see division in this inequality, the inverse operation would be multiplication. So we multiply both sides of the inequality by the same positive number. 4 in the numerator is going to cancel 4 in the denominator. I have x is going to be less than 8. So we're saying the solution of this inequality would be any value that is less than 8 is going to make that inequality true. So let's try something like 4. Is 4 divided by 4 less than 2? Sure it is, because 4 divided by 4 is 1. 1 is less than 2. So that's the multiplication property of equality, of inequality, which says you can multiply both sides of an inequality by a positive number, and the inequality remains true. We also have the division property of inequality, which says when you divide each side of an inequality by the same positive number, the inequality remains true. Let's start with the same inequality we did with the first example. 8 is more than 6. If I divide both sides of that inequality by the same positive number, let's say we divide it by 2. 8 divided by 2 is 4. 6 divided by 2 is 3. I still get an inequality that's true. 4 is more than 3, just like 8 is more than 6. We can use that division property of inequality to find solutions to inequalities. This inequality says 4 times the number x is less than 8. I want to know what are the values for x that would make this inequality true. 4 times what number would be less than 8? Well, I use the inverse operation to find solutions. I see multiplication. The inverse operation would be division. So we divide both sides of the inequality by the same positive number. 4 divided by 4 is 1x, or 1. I write 1x like that. 8 divided by 4 is 2. So we're saying any number that's less than 2 is going to make this inequality true. So let's try 1, because 1 is less than 2. Is 4 times 1 less than 8? Yes, it is. So we're going to be using these properties of inequality to find solutions. Okay? So let's take a look at our first example. All right? I always like to rewrite the inequality, so I'm going to rewrite it here. It says a number divided by 5 is less than or equal to 2. We want to find the values for x that are going to make that true. What number, when we divide it by 5, are you going to get values that are less than or equal to 2? Well, to find the solution, or the solutions of that inequality, I have to use the inverse operation. Because I see division, the opposite of division, or the inverse operation, would be multiplication. Well, what do you multiply both sides of the inequality by using the multiplication property of inequality? Well, whatever is dividing the variable, that's what you use to multiply. So because I see the variable being divided by 5, I'm going to multiply both sides of the inequality by 5. 5 in the numerator is going to cancel 5 in the denominator. You're left with 1x on the left side of the inequality. The inequality symbol does not change, so it remains less than or equal to 2 times 5 is 10. We're also asked to graph the inequality. So we would draw a number line quickly. We always locate 0 on the number line. Then I locate the number in the inequality. That's 10. Less than or equal to means we have a closed circle. So we fill in that circle and all of the values to the left of 10. Because the inequality symbol is pointing to the left, all of the values that are less than 10 or to the left of 10 are going to make that inequality true. So let's try something like 5, right? Because 5 is less than 10. Is 5 divided by 5 less than or equal to 2? Right? Yes, it is. So I feel good about that solution. All right, let's look at these 3 examples. All right, we'll work on these. Problem number 1, we write it this way. We say a number divided by 3 is greater than 2. I don't like my students using that division sign, so I like for my students to rewrite division problems this way. They recognize division and they use the inverse operation. The inverse would be multiplication. I show multiplication this way, multiplying both sides of the inequality by the same positive number. 3 in the numerator is going to cancel 3 in the denominator, so I'm left with 1p is greater than 2 times 3 is 6. If we're graphing that solution, we locate 0. 6 is to the right of 0 on the number line. It's an open circle, and my solutions are going to be to the right of 6 on the number line. Let's try problem 2. 3/5 times q is less than or equal to 6. If you remember when we had these one-step equations, I see that my variable is being multiplied by 3/5. I use the inverse operation, right? So instead of multiplying by 3/5, we're going to divide by 3/5 on both sides of the inequality. That becomes 1. 1q, I write that way, is less than or equal to. Well, what is 6 divided by 3/5? Well, 6 divided by 3/5 is, right, well, let's do it this way, is the same as 6 times 5 over 3. When we divide fractions, we multiply by the reciprocal. 6 times 5 is 30. 30 divided by 3 is 10. So we have q is less than or equal to 10. All right. Let's see. And, we have to graph that solution. So I have my number line. I locate 0 on the number line. Here's 10. 10 is to the right of 0 on the number line. It's circled and filled in, so it's a closed circle. Solutions are going to be going to the left. All right. And then let's try problem 3. Problem 3 is going to be 1 is less than s, or a number, divided by 7. We see division, and the opposite of division is multiplication. So I'm going to multiply by 7 on both sides of the inequality. 7 in the numerator is going to cancel 7 in the denominator. So we have s left on the right side of the inequality. On the left side, 7 times 1 is 7. But we have to recognize this is a reversed inequality. We talked about this in a previous lesson. What's a reversed inequality? A reversed inequality is when an inequality is written with the variable on the right side of the inequality symbol. Notice these solutions here, variables on the left side of the inequality symbol, variables on the left side of the inequality symbol here. Well, what's the importance? The importance, when the inequality is written this way, is that the direction of the inequality symbol here is the direction of your solutions. The direction of your inequality symbol here are the direction of your solutions. When you have a reversed inequality, the opposite is true. So we locate 0 and we locate 7 to the right of 0 on the number line, and we're going to circle 7, and it's going to be an open circle. But because it's a reversed inequality, our solutions are in the opposite direction of our inequality symbol. So the solutions are going to have to be to the right of 7. Well, let's check it. What's a number that's to the right of 7 divisible by 7? Let's try 14. Is 1 less than 14 divided by 7? Yes, it is, because 14 divided by 7 is 2. 1 is less than 2. All right, so make sure we have to pay attention when an inequality symbol is reversed. All right, let's look at using division. Okay, we have 4 times a number is greater than 32. I'm going to recopy it here. 4 times a number greater than 32. We recognize multiplication in the inequality, and the opposite of multiplication is division. So I'm going to divide by whatever is multiplying the variable. That's what we divide by. 4 in the numerator is going to cancel 4 in the denominator. That becomes 1n. It's going to be greater than 32 divided by 4 is 8. I graph that solution. I locate 0. 8 is to the right of 0 on the number line. It's an open circle because it's a greater than sign. And because the inequality is written correctly, the direction of my inequality symbol are going to be the direction of my solutions. Well, let's check it. Right? And we're saying anything to the right of 8 on the number line is a solution. So let's try 10. 10 is to the right of 8 on the number line. Is 4 times 10 more than 32? Yes, it is. So I just want to try to check those solutions, right, and make sure that your solution is going to make sense. All right. We have a word problem here. It says a one-way bus ride costs $1.75. A 30-day bus pass costs $42. Part A says to write and solve an inequality, to find the least number of one-way rides you must take for the 30-day pass to be a better deal. Okay? Well, we know that we're paying $1.75 for each ride. And we want to know, well, when is that going to be more than $42, right? Because then it's not a better deal. And we want to know when the 30-day bus pass is a better deal. So I'd have to write this inequality. I see that this inequality has multiplication, so the inverse operation would be division. So we're going to divide both sides of the inequality by $1.75. On the left side of the inequality, $1.75 in the numerator is going to cancel $1.75 in the denominator. You're left with R is greater than, well, what's 42 divided by $1.75? Go over to the side of my paper and do that. 1.75 into 42. All right. Slide, 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 slide. Decimal point goes in your quotient. That's going to be 2. 2 times $1.75, that's $3.50. I subtract, that's going to be 0, that's going to be 7. And then that's going to be a 4. And 4 times $1.75, that's 0. So R has to be more than 24 rides. So if we have more than 24 rides, the bus pass is going to be a better deal. All right, so it says, write and solve an inequality to find the least number of rides of one-way rides you must make or take for the 30-day pass to be a better deal. Well, the least number of rides has to be anything more than 24, right? So anything more than 24, which means 25 rides, would be the least number. All right, let's do part B. Part B says you ride the bus an average of 20 times a month. Is the pass a better deal? Explain. Well, what do you think about that? Well, we're saying part A says that the number of rides has to be more than 24 for the pass to be a better deal. Is 20 more than 24? Right? The answer to that is no. All right, so no. Is the pass a better deal? The answer is no, because 20 is not more than, right? 20 is not more than 24. All right. Continue with some examples. Here's some on your own problems. Why don't you guys try those? Stop the video. See how you guys do with that. Right? But I'm going to work on them. So you guys can start the video when you're done and, check your answers. All right. Problem number 4, we have 11 times some number k is less than or equal to 33. And I look at that inequality and I say, okay, well, what operation do I see? And I see multiplication. The opposite of multiplication is division. Well, what am I going to divide by? I divide by whatever is multiplying that variable. So because 11 is multiplying the variable, that's what you're going to divide both sides of the inequality by. 11 in the numerator cancels 11 in the denominator, so I'm left with 1k is less than or equal to 3. If I'm graphing that solution, you guys know I always want you to locate 0. 3 is to the right of 0 on the number line. It's going to be a closed circle because it's less than or equal to. And our solutions are going to go to the left. All right, let's try problem 5. Problem 5, we have 5 times a number j. It's going to be more than 20. I see multiplication, so the inverse operation to find the solution is going to be division. So I'm going to divide by whatever's multiplying the variable. So I divide by 5 on both sides of the inequality. 5 in the numerator is going to cancel 5 in the denominator. I'm left with 1j is going to be greater than 20 divided by 5 is 4. All right, I want to graph that. I have 0. 4 is to the right of 0 on the number line. I have an open circle, and my solutions are going to go to the right of 4 on the number line. All right, let's try problem 6. We have 50 is less than or equal to 2 times the number m. You should recognize before you even begin that the variable's on the left side of the inequality symbol, so we're going to have a reversed inequality, and we have to pay attention to our graph. I want to find the solution to this inequality. I want to use the inverse operation. I see multiplication, so the inverse operation is going to be division. So I divide by 2 on both sides of the inequality. 50 divided by 2 is 25. It's less than or equal to 1m. I see that it's a reversed inequality because my variable is on the right side of the inequality symbol, but I still find 0 on the number line, and I know 25 is to the right of 0. Right? It's going to be a closed circle, right? Because it's less than or equal to, but because it's a reverse inequality, my solutions are going to be to the right of 25 on that number line. All right? Let's look at number 7. Number 7 asks us, or says, the sign shows the toll for driving on Alligator Alley, right? So we're talking about this sign here. Write and solve an inequality to represent the number of times someone can drive on Alligator Alley with $15. Well, if I'm writing the inequality, I have to think that $2.50 for each ride has to be less than or equal to 15, because if I only have $15, my tolls could be less than $15, my toll could be equal to $15, but if I only have $15, I can't spend more than $15. So that's the inequality I'd have to write using the less than or equal to symbol. To solve that inequality, I use the inverse operation. I see multiplication. The inverse operation would be division. So I'm going to divide both sides of the inequality by 250. On the left side of the inequality, 250 in the numerator. It's going to cancel the 250 in the denominator. I'm left with 1r is less than or equal to. I can do my long division over here. $2.50 into 15. Got to slide my decimal point 2 places in my divisor, 2 places in my dividend. Decimal point goes in my quotient. Let's see, 250 can't go into 150, but 250 into 15 goes what? Well, 250 goes into 5 twice, and that goes 5 goes into 15 3 times, so that's got to be a 6. 6 times 0 is 0. 6 times 5 is 30. Carry the 3. 15. Beautiful. So that is going to be 6. R has to be less than or equal to 6. I'm graphing that solution. I have 0, 6. It's a closed circle at 6 on the number line. Solutions are going to go to the left. All right. Just a couple more examples. Almost done. All right. If you guys wanted to try to practice these on your own, you could. All right, let's see, but I think that's it. Yeah, that's going to be it. All right, I just wanted to double check. See how much more we had to go. I'm going to recopy 5x less than or equal to 45. We see multiplication, and the opposite of multiplication is, or the inverse is division. So I'm going to divide by 5 on both sides of the inequality symbol. 5 in the numerator cancels 5 in the denominator. I'm left with 1x is less than or equal to. That's going to be 9. The graph, locate 0. 9 is to the right of 0 on the number line. It's a closed circle at 9. Solutions are going to go to the left. Our next example, right? I want to recopy. A number divided by 8 is greater than 3. We see division, and the inverse operation then would be multiplication. So I'm going to multiply by 8 on both sides of the inequality. And I like for you guys to use parentheses when you show that. 8 in the numerator is going to cancel 8 in the denominator. We're left with 1x. It's going to be greater than 3 times 8 is 24. I'm graphing that solution. I locate 0. 24 is to the right of 0 on the number line. It's an open circle because it's a greater than symbol. Solutions are going to be to the right of 24 on the number line. And always check it if you're not sure. So I'm going to pick something that's more than 24. Let's try 32. 32 divided by 8 is 4. 4 is greater than 3. So my solution looks good. All right. If you guys want to try these on your own, right, stop the video, try it. If not, I'm going to go through the examples. All right. Dividing both sides by 10, they cancel. X has to be less than 8. So I'm circling 8 on the number line. Solutions are going to be to the left. Your next example here, I see division. The opposite of division is multiplication. So we're going to multiply by 6 on both sides of the inequality. 6 in the numerator, cancel 6 in the denominator. X is going to be greater than or equal to 42. Circle 42. It's a closed circle. Solutions are going to be to the right of 42 on the number line. All right. And our last problem here is going to be a word problem. Laverne is making bags of party favors for each of her 7 friends attending her birthday party. She does not want to spend more than $42. Well, if she doesn't want to spend more than $42, we know we could spend less than $42. We could spend equal to $42. So I know that that's going to be, the right side of my inequality. Write and solve an inequality to find the maximum cost for each party favor, right? And the key word there is maximum, which is associated with the inequality symbol less than or equal to. We have 7 friends, and each of those 7 friends is going to be getting party favors. So I'm going to say 7F, right? 7 favors have to be less than or equal to 42. If I'm solving that inequality, we're dividing by 7 on both sides of that inequality. So we're going to have F is less than or equal to 6. They're not asking us to graph the solution, so I won't graph it. All right, but that's going to be it today, guys. All right, so you have a bunch of examples there. You may want to go back through those examples if I want a little quickly. But, for the most part, solving inequalities are the same as solving equations. We're using the inverse operations. Key, though, you have to pay attention when the inequality is a reversed inequality because that makes your graph a little bit tricky. Reverse inequality, the direction of the inequality symbol is going to be in the opposite direction of your solutions on the graph. All right? Well, good luck with your work there, guys.